Hello and welcome to Controlling Water, a space for us to talk valves, water meters, and interesting insights about the water industry. Each episode, we're joined in conversation by industry professionals that specialise in all things valves, meters, and best practice knowledge in the water industry. We're here with Colin Kirkland from Bermad Water Technologies, who is one of the engineers at BWT. Colin has over 30 years industry experience in working in pipelines that can be subject to water hammer. Colin, I'm really excited to talk to you about this today. Water hammer is a topic and an area that we hear a lot about.
It is.
And it's also something where huge ramifications and consequences can occur if it's not managed well or if it's not prevented or stopped. Before we get into some of the detail about water hammer, can you tell us what actually is water hammer?
Yeah, well, water hammer is a phenomenon that occurs where you see a very quick, rapid increase in pressure way and above what you would normally expect in a pipeline, generally caused by a rapid change of flow in a pipeline. A really simple way of explaining this is the domestic household situation in our house. I know it happens. When our clothes washing machine, when we start that and the solenoid valve opens and the water runs into the clothes washer, when the water fills up to a level, the solenoid turns off and you hear a bang. And that's because we've got a rapid change of flow happening because the valve shuts off instantly, pressure builds up and shakes the pipes. So that's a small domestic situation of water hammer and can be changed. But the same thing happens in very large pipelines, whether it be in a mine or water supply, to quite serious ramifications because it's tons and tons of water that you're potentially moving.
No doubt. Wow. And so when this water hammer condition happens in a pipeline,
yes,
what are some of those ramifications? And is it dangerous as well?
Certainly it can be dangerous, yes. So depending on the pipe material you've got, these pressure waves can run along the pipeline at very fast speeds. So in metallic pipe, for example, where it's very, very rigid, it can run up to 1,000 meters per second.
Wow.
So you might get a spike at a pump station and 1 second later, a kilometre there, that pressure wave is transmitted through there. So it resonates through the whole network. The important thing is that when you see these pressure spikes, the network has to be able to cope with these. Now, like anything else, if you constantly fatigue a system by pressurising it to a dangerous level, it can fail. I've been in pump stations where I've sat at a pump station and they've turned the pumps off, and it's quite scary when you hear the non-return valves close and you hear this massive bang and everything shakes and it's dangerous sort of thing. So, and we've had instances where if the products fail through fatigue and the excessive pressures, that can be dangerous to operators too as well. So
absolutely.
Yes, it can be quite scary.
Absolutely. Oh my goodness. So what are the most common locations where water hammer happens in a water supply pipeline? Can we talk about that?
Typically it'll happen in about 3 different locations, Sarah. So anywhere where the water flow changes rapidly is where this is going to occur. So if we think about a pumping station pumping to a reservoir, when the pump stops, that's when the flow instantly changes. Now, if the pump slows down and ramps down very slowly, you don't get the water hammer. But if it just stops instantly, that's where we see it. Or you may see, for example, if you're pumping to a reservoir, we may have a valve at the reservoir that says, when I close, if I close too fast, I'm going to generate that water hammer, just like the washing machine effect.
Right.
Or it could be that we've even got on a pipeline a situation where the pipe is partially empty and you start the pump and that water columns come together. And when the two come together, they generate a rapid change in flow, and that can cause there. I've even been on pipelines where I've heard operators running from the site because they've closed a valve too fast and they've heard air valves screaming. And that's not a great situation, you know. These situations occur and people are not quite sure why they occur, but it can happen in multiple locations along a pipeline.
That must be so scary to hear that on site.
Well, it can be.
And then have to run.
Well, it can be. That was an actual instance which we had on a pipeline where we had a 1 metre diameter butterfly valve closed too quickly and the air release valve next to it went into massive vacuum and the operators could hear this massive air being drawn in and ran from the site because they thought something was going to explode. And it wasn't good.
No.
It wasn't good.
Not at all.
Yeah.
So having understood the areas that generate these water hammer issues, how does Bermad go about rectifying the solutions?
There's two ways we look at it, Sarah. You can look to see what's generating the problem, and you can try to rectify that. So as an example of that, if the pump station was the situation that was generating the problem, because when they turned the pump off, it turned off in 2 seconds, and they used to see a great amount of water hammer happen at the pump station. So what could we do? We could extend the pump to make it run and shut over 30 seconds or 40 seconds and reduce that. Or what we could do is we could say, well, look, let's just put a Band-Aid on it and put a pressure relief valve that if the pressure does rise when we shut it off too quick, I can release. So it's a case of one of two things. Let's look to see what the problem is and try and rectify that, or let's put a Band-Aid on to react to it.
Right.
Now, the logic between going with one or the other is the practical nature of it. It might be very expensive to put a solution in to stop the actual pump running down very slowly. We might have to put a pump control valve in there. It might cost $20,000. Or they might say, look, Colin, we've only got 5 years left on this on the mine. Let's just put a relief valve in that can take out that spike, keep it all safe. It might cost $3,000. So it's the practical and the cost nature of what look at, but we look at it both ways. Yeah, try and fix the problem from happening or react to it.
Definitely. And I guess it would always just depend on the situation
Completely.
at hand.
Completely. And the application too, Sarah. So it might be that you're doing this on an irrigation property where the irrigation grower, he's spending his own money.
Right.
And you know, the farm might just wants an inexpensive solution that's not too costworthy, but fixes it. Or it might be a mine where you're 2 kilometres underground, and when they turn that pump off, it's seriously dangerous to the operators down there.
Yeah.
They want the very best solution that's going to fix it. So it could be that it's the water supply where we've got 40% of the water for a major city. We don't want that to fail.
No.
So let's put the most robust, best system in to maintain that. So it's all horses for courses, I guess.
Definitely, definitely. Let's take a short break before we return to chat about minimising water hammer in complex installations with varying topographies. You're listening to Controlling Water, the Bermad podcast, your primary source of insight for everything about water tech, valves and meters. For more information on any of the products or topics discussed in this episode, plus a wide range of resources and articles designed to support you as water professionals, visit bermad.com.au. Now, back to the show. So understanding these two general approaches to fixing the problem, where do you start to see what the best solution might be?
Yes. From our perspective, we're not a consultant. We are an engineering company that produce solutions that we can put onto pipelines. A company, of course, can go to an independent consultant. And today, Sarah, there's many sizing modelling softwares that is around, such as Bentley, Hammer, KY Pipe, Hytran. There's many of them. But what these modelling softwares enable you to do is to accurately input the data of the pump, the pipe, and the network, and actually see what happens. If I stop the pump in 10 seconds or 2 seconds, or if I have a power trip and the pump stops instantly, this is what will happen. And then they can identify and see how it's going to affect the system and make suggestions. They may want to put a surge tank in, they may want to put a pressure relief valve, or an anti-slam air release valve, or they may want to put a pump control valve in. There's many, many different ways you can look at it. So from our perspective, we have almost 30 years experience in Australia in doing this. So although we don't do the modelling, we work with the modelers to show them how the valves are going to respond and do that. But we also have a lot of practical experience. So we commission a lot of our valves, we engineer them and make sure they work, and we see them in action. So modelling and actually experience is two completely separate things. And sometimes you will see a report from a modeler that just doesn't look right.
Right.
And it's usually because it's got a wrong input data. And we have that experience to be able to share that so we can make the solution the best one.
Yep.
So from our perspective, we look at it from a experience. We know typically what works. And if you want to back it up, you've got that software you can go to. Companies to get that as well.
Definitely. It's a really interesting point that you make around the ability to call out a potential error in modelling software through the years of experience.
Yes.
It also sounds like there's a high value in being able to overcome blind spots, whether that's through the software and being able to emulate situations or knowing actually that doesn't look right and this is why.
And look, you're very true there, Sarah, because what a lot of these programs assume is that the pipeline is completely filled full of water. Because water is non-compressible. But if there were pockets along the pipeline that had air in them, that were compressible, that can accentuate areas at different locations. So it's making a lot of assumptions.
Yes.
And look, also the software is not perfect, but it's come an awful long way. And what we see coming from there and the reports is fantastic, when it's done well. But it's not only just about having the software, but it's actually having the engineer who really understands the software and knowing how to input the right data. And that takes a lot of experience. That's why that's left to specialists that do that, not me. But a lot of the time, the practical hands-on side of it also assists that in coming up with a good solution, because the solution might not be practical.
Very true. Very true. It's really interesting that you mentioned air release valves.
Oh, yes.
We've talked about that many times,
yes.
And we've certainly discussed the engineering benefits and some of the water hammer issues using air release valves.
Yes.
Do air valves on the pipeline prevent water hammer in the network?
Yes and no. So when you're using that modelling software, typical air release valves, and what we're talking about there is a combination air valve. So that would mean if we had an 80 millimetre valve, it has an 80 millimetre orifice for air intake, an 80 millimetre orifice for discharge. Some air valves, if there's column separation, and that's where we have the pressure going into a negative, where we're drawing large amounts of air in, and then the columns come back together, they can generate localised water hammer at strategic locations. So they're very good at protecting the pipe against vacuum, very good at evacuating it, but with the wrong product and the wrong application, it can make it worse.
Right.
And that's where there are products in the market today which are called RFP, rapid filling prevention valves, or anti-slam air release valves, or surge prevention air valves. What these basically do is they say, I'll allow large amounts of air to come into the pipeline, but I will let the air out at a slower, controlled rate.
Right.
And there's various ways that they actually achieve that function, but they're very safe, and they can be modelled very simply and easily on this software as well.
How interesting. And so, Colin, where should people start when they're considering how to fix a water hammer issue?
Well, it depends on the application and its complexity. What we're always trying to do, if they come to us at Bermad Water Technologies, we don't provide this modelling software, but we provide 30 years of experience in getting it right. We can certainly give them advice on what's generating the problem. And we tend to say, well, we come to site sometimes, or we'll discuss it on the phone or via Zoom meeting, whatever, and we'll be able to come up with what we believe is a solution. We'll be able to give them some advice on how to install it, how it's going to act, and also give them advice that if they actually want to model it and go to an independent company, we can show them how that works and they can prove it. So a lot of the times before you buy something, you want to know, is it really going to work? Well,
definitely.
We give a lot of references out for jobs that we've got, and we've shared a lot of jobs that work well and don't work as well. And we've got, the experience is the big thing, Sarah, because you learn from mistakes a lot of the time, and sometimes you make assumptions which is incorrect. And that's because we don't see what's actually underground. We don't know if the pipe material was steel or if it was PVC, and that has an influence on how the valve reacts and speed, etc. So it's quite a complex issue, but where do you start? We're a very good starting point to be able to start that conversation going, for sure.
Fantastic. Great to hear. Colin, thank you for joining me today. It's been a great conversation about water hammer.
That's great. Thank you.
Wonderful. For more learnings about the water industry, including products, tips, installations, operation and maintenance techniques, head over to bermad.com.au and subscribe to our industry newsletter. You'll join more than 3,000 industry professionals and learn from the experienced Bermad team of industry specialists. Thanks for tuning in to this episode of Controlling Water. For more episodes, resources and how-tos, head to bermad.com.au.